All right, guys, this is the last section that we're going to cover in our little geometry section. This is called trigonomic ratios. And you will need your graphing calculator for this, so go ahead and go grab it and come back and play me when you got your calculator. Okay, here's a couple key concepts. I'd like you to get these in your notes and replay me when you're ready for an explanation. So basically the definition of trigonometry is the study of relationships among the angles and sides of a triangle. Okay, so we're going to be looking at lots of triangles today, their angles and their sides. And basically that's trigonometry. A trigonomic ratio is a ratio that compares the side lengths of two sides of a right triangle. Okay, and the three most common trig ratios are sine, cosine, and tangent. And here in this box, I've got an example of this triangle right here, ACB or ABC. And we're looking at angle A. Let me erase this. We're looking at angle A right here. Okay, so the sine of A is going to be the leg opposite of angle A over the hypotenuse. Okay, so the leg opposite from angle A and the hypotenuse. And remember we talked about the hypotenuse being directly across from the right angle. So this right here is going to be A over C. The sine of A is A over C. Cosine of angle A. We're still looking at angle A. Here, we're still looking at angle A. And cosine is adjacent. So we want the sine, the leg that is right next to the angle. Okay, so we've got B over the hypotenuse. Remember that hypotenuse is still the same one across, directly across from that right angle. So we have cosine of A is B over C. And then finally, we've got our last trig ratio as being the tangent. And let me erase this real quick. And the tangent is just simply opposite over adjacent. So we're still looking at this angle A here. And opposite is A, and adjacent, the one right next to it, is B. So tangent of A is A over B. And those are our three most common trig ratios. Okay, here's a couple more key concepts. Go ahead and get these in your notes and replay me when you're ready. And I'll explain what this means as soon as you get it copied in. Okay, so to find the missing sides of a triangle, so we're going to be given a triangle, it's going to be right. And remember, if we're missing one of the sides, we can use Pythagorean's theorem. We talked about that. It's a squared plus b squared equals c squared. So we're going to use that today. We're also going to talk about, if there's a missing angle. And remember that triangles add up to be 180 degrees. Okay, so we can find angles. If we're missing one of them, we know that they are 180 degrees, and if we're missing one of the sides, we can use Pythagorean's theorem. Okay, and then we're going to use the term solve a triangle. And you might ask, well, what the heck does solve a triangle mean? Well, it is meaning you are finding all the sides and all the angles of a right triangle. So every side you'll find and every angle you'll have some value for. Okay, and that's called solving a triangle. And then finally, there's this kind of weird word down here, these bunch of random letters. And this is in how we say this is called SOHCAHTOA. SOHCAHTOA. And this is kind of a mnemonic device to remember this right here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Look at here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's just kind of a little mnemonic device if you'd like to use that to remember those. Okay, so here it says to find the values of the three trig ratios for angle A. Okay, so we're going to be working with this angle right here, angle A. And I want to find the three trig ratios for that. So I had sine, cosine, and tangent. Those are my three trig ratios. Woo, mouthful. Okay. Now, before I start getting started on these trig ratios, I want you to look at our triangle here. We've got a triangle, but we've only got two sides. And I need this third side in order to find my trig ratios, because my trig ratios involve all three sides. So I've got to find this third side in order to do my trig ratios. So we'll do that now. And remember, we find that using the Pythagorean theorem. So 9 squared plus b squared equals 15 squared. 9 squared is 81 plus b squared equals 225. B squared equals 144. And b equals 12. So we're going to stick 12 up here. B equals 12. Now we're going to find all of our trig ratios for angle A. So the sine of A is opposite the angle, the side opposite from A, which is 9, over the hypotenuse, which is directly across from the right angle, which is 15. We reduce this as sine A equals 3/5. Okay, the cosine of A is going to be the side adjacent to A, which is 12 over 15, which is our hypotenuse. And we reduce this to, not sine, cosine of A, which is 4/5. And then finally we have the tangent of A, which is opposite over adjacent, which is 9 over 12. Oops, my 12 kind of erased over there. And tangent of A reduced 9 over 12 is 3/4. Okay, so those are our trig ratios for angle A. Okay, same triangle. I'd like you to try and find the trig ratios for angle B. And we just solved this, so you don't actually have to solve this again. And that was 12. Replay me when you're ready for the answer. Okay, so sine of B was 12 over 15, which reduces to sine B 4/5. Cosine B, 9/15, which is sine B of 3/5. And tangent of B equals 12 over 9, which equals sine of B equals 4/3. Oh, wrong way. Okay, now here's where your calculator is going to come into play. I'd like you to use a calculator and round to the nearest 10,000ths. So we're going to plug all of these into our calculator. The first one I want you to type in is cosine of 42. Now I kind of put in a little bit of screenshots of your calculator. So the keystrokes here, you're going to hit a cosine. That cosine is right above the numbers. Cosine, the number 42, in parentheses, and enter. And this is what your calculator screen will look like. If for some reason you get negative 0.3999, blah, 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 I want you to do this real quick for me. If you have 0.74, you can just go ahead and fast forward me. But if you do get a negative 0.3999, listen to this real quick. I'd like you to hit the mode button on your calculator. It's the top left next to the second button. Use your arrow keys and arrow down until your cursor is on radian. It's the third one down. It will be blinking. arrow to the right, so your cursor is on the degree, and hit enter. Now your degree should be highlighted. Hit second mode and try cosine 42 again. Okay, hopefully you get 0.743144825, and so on. Okay, so now we've got all our calculators together. I want you to try 2, 3, and 4 for me, rounding to the nearest 10,000ths. When you're finished, replay me for the answer. So sine of 31 is 0.5150. Tangent of 76 is 4.0108. And cosine of 55 is 0.5736. All right, and then we've got solving the triangle. Remember, we talked about solving the triangle as finding every angle and finding every side. Okay, so first of all, we are going to use that property of a triangle is adding up to all the angles add up to 180 degrees. So I see that I'm missing this angle A right here. So I have a 90-degree angle, I have a 41 degrees, and I'm missing one. So I'm going to go ahead and find that one first. So to find angle A, and this is a little symbol for angle A is 90 degrees plus 41 degrees plus x equals 180. 90 plus 41 is 131 plus x equals 180. Minus 131, x equals 49. So this degree right here is 49. Okay, so we got all our degrees. Now, I'm missing this A and I'm missing this C. Okay, and I don't have enough information in order to do the Pythagorean theorem. However, I do have what's called the trig ratios. So that's where I'm going to use this. Now watch this closely. We want to use this we want to use this angle right here because that's the one given to us. We don't necessarily want to use 49 just in case we made an error somewhere here with the arithmetic. So we want to use the one that's given to us. We don't want to use 90 degrees because we can't use the right angle ever. So we're going to use this, this 41. So what we do have is we do have an opposite side. We're missing the hypotenuse and we're missing the adjacent side. So I'm going to use something that is dealing with the opposite and the hypotenuse. And if you can remember, that opposite and hypotenuse, that was the sine. So I'm going to find the sine of 41, that's that angle, and the sine of 41 is opposite, which is 6. Hypotenuse is C. Okay, and that's just opposite over hypotenuse. I know my 41 degrees is that little angle right there. And so now I'm just going to solve. Okay, how would I normally solve this if, we didn't have that trig ratio in here? How would I solve for C? Well, we would multiply by C on both sides so we can get it out of the denominator. And this would be C sine 41 equals 6, and then I would divide by sine 41. And this is all just trying to get C by itself, and 6 divided by sine 41 is impossible to do. Well, it's not impossible, but it's pretty hard to do in your mind, so you can just literally just do this in your calculator. 6 divided by sine of 41, and we get C to be 9.1, or approximately. We're going to round. Okay, so now we've got this to be 9.1. And then finally, we're going to do this last leg here as A. And this is, we've got an adjacent side, and we've got an opposite. And again, you don't want to use one of the values that you've actually found because you don't want to have a mess up anywhere. So you want to use values that are given to you. So let's see, what uses opposite and adjacent? Well, tangent does, doesn't it? So we're going to do tangent of 41 equals 6, opposite, which is 6, over adjacent, which is A. And we're going to solve this for A. So we've got to get it out of the denominator, just like we did before. Those cancel. So I'm left with 6 A times tangent, 41, divide by tan, 41, divide by tan, 41. Those cancel. A equals 6 divided by tangent of 41 is 6.9. And now we have all of our angles and we have all of our sides, and this triangle is solved. I want you to try this one and really try it all the way through before you replay me. And when you're ready for the answer, go ahead and play me. Okay, so we've got to find angle B first. And angle B is, how we find that is we add up the other sides, 90 plus 35 plus x equals 180. And we find out x to be 55. And we know that we have this angle right here. We're missing two sides, so we can't do Pythagorean's theorem. So we've got to use our trig ratios. We've got this angle 35 degrees. We've got this 7. We're looking for, let's call this x and this y, or however you labeled it is fine as well. So we're looking for this x and this y. Okay, so we can do the first one as sine of 35. The opposite of 35 is x, and we are looking for the hypotenuse, which is 7. And here, we're just going to solve for x, and all we have to do here is just multiply by 7. And we have 7 times sine of 35, and you just punch that in the calculator, 7 times sine 35, and we get 4.0 for x. This was 55 degrees here. And finally, we're going to find that y up there. So we say the cosine of 35 equals the adjacent, which is y, that adjacent, and we're looking for the hypotenuse, which is 7. We multiply by 7 on both sides. And again, we just say 7 times cosine 35 right into that calculator, and you get 5.7 equals y. That one was a little bit easier. Hopefully you guys got that one. Here's your practice problems. I know there are quite a few, but I do want you to get them as much as best you can. 5 through 8 should take a half a second. So hopefully you guys don't take too long on these. Good luck. We'll go over them next time we see each other.